Hello students, in the previous video we learnt chapter number 2 is that the Pythagoras theorem. Afterward we are going towards the next chapter in the 10th standard of mathematics part 2 is that the circle. We learned in the previous standard the concept of a circle and we are familiar with regarding circle like radius, diameter, chord of a circle and the exterior and interior part of the circle. And also we learned the circles in a plane. That means, look at here in the figure. Suppose if we take in the first figure a circles with centers P and Q having a equal radii or length of radii are equal, then we say that the circles are congruent circles. Look at here. PA and QB are the respective radii of that circle are congruent. Then we say that the circles are congruent circles. Okay. Now in the second figure, both the circle having the same center, which is the O here. Okay. A smaller circle and a larger circle having the same center, then that circles are known as the concentric circles. Also we learned when your circles intersect each other in a two distinct point, in that figure the circles with centers P and Q respectively intersect each other at point A and B, then we say that such circles are intersecting circles. Okay, that part we learned in the previous standard. Also we learned the concept of properties of chords. What are the properties of chords? Look at here. When you construct the chord to the circle and a perpendicular drawn from center to the chord, what happens? Look at here. We learned that property. Suppose that AB is a chord and PM is a perpendicular drawn from the center to that chord. What happens? When you construct the perpendicular from center to the chord, then that perpendicular bisect the chord. Okay, here P is the center of circle and PM is a perpendicular to the chord AB. Then we say that segment AM is congruent with segment MB. That means the perpendicular drawn from center to chord, it bisects the chord. Now second property we learned previously is that suppose that a circle with a center Q having the chord PR, okay, having the chord PR and M is the midpoint of that chord PR. M is the midpoint of that point QR. Then what happens? Look at here. What is given here? M is the midpoint of the chord and QM is a segment joining the center and midpoint of the chord. Then what happens? If Q is the center of circle, M is the midpoint of the chord. What is given here? M is the midpoint. That means here PM is equal to MR. That's the given. And from that, what do we get? QM is a perpendicular to the chord PR. That means a segment joining the midpoint of the chord and the center is a perpendicular to that chord. Okay, that concept we learned previously. And also in case of the congruent chords, suppose if we consider the congruent chords to the circle, look at here, congruent chords to the circle and draw the perpendiculars. Suppose that P is the center of circle and first chord AB and second chord is the CD. Both are the congruent chords. P is the center of circle, AB and CD are the congruent chords of the circle. Then what happens when you construct the perpendicular, that means the distance of the chord from the center, that is the PM here. Also we construct the perpendicular here. Look at here. Let's see the perpendicular from center P to the chord CD is the PN. Then what happens? That's chord AB is congruent CD. That is the given. Then what happens? The distance of that chord from the centers are congruent. That means here we get PM is congruent with PN. That's are the distance. That means the congruent chords at a congruent distance from the center of the circle. That's the three properties we learned previously. Okay. Also we learned the property of the congruent chords. That means the congruent chords are congruent distance from the center, and also congruent chords make a congruent angle at the center. Suppose that in that case both the chords are congruent, and when you consider their endpoints of the center, we get the angles here. Angle APB and angle DPC both are also congruent. That means here we learned previously is that the congruent chords makes congruent angle at the center, and also the congruent chords at a congruent distance from the center. We are familiar with that concepts. Okay. Now we are going towards the new concept is that the circles passing through the 1, 2 and 3 points. Take a point A in the plane of a circle and try to construct a circle passing through it with the help of a compass. Take a suitable distance in your compass and complete a circle passing through the point A. Also take another distance in your compass and try to complete a circle passing through it. Okay, in a such way that how many circles are passing through that given point. Look at here. If we construct the circles passing through that single points, we get infinite circles. Infinite circles. Many circles are passing through that single points. Look at here. Okay, that's with a different radii. म्हणजे जर आपण या प्लेन मध्ये ए पॉइंट घेतला आणि त्या ए पॉइंट मधून आपण सर्कल पास करण्याचा प्रयत्न केला, तर आपण डिफरंट रेडिया घेऊन मेनी सर्कल्स कन्स्ट्रक्ट करू शकतो की दॅट सर्कल्स पासिंग थ्रू दॅट पॉइंट सिंगल पॉइंट ए. दॅट मीन्स infinite circles passing through one point. Okay, now we are going towards the what happens when you take the 2 points. Suppose if we take the 2 points which are the P and Q, then how many circles are passes through it? That is simple fact. Look at here. When you join the point P and Q, we get the segment PQ. Okay. Then construct the perpendicular bisector of that segment PQ. Okay. Afterward, we get the distance PM and MQ are congruent, and L line is a perpendicular bisector of that segment PQ. That means every point on that line which is equidistant from the endpoint of that segment PQ, that means the endpoint P and Q. We take a compass and take the centers as A, B, C, D, E and try to construct the circles. Then every circle is a passing through, look at here, that every circle is a passing through that point P and Q. Why? If we join the PA and AQ, we get the PA is equal to AQ. Why? By the theorem of perpendicular bisector. Also we get the PE is congruent with AQ. Okay, that means infinite circles we construct here, taking a point on that bisector of that segment PQ, and that circles passes through the point P and Q. Okay, and henceforth we say that infinite circles are passing through given two distinct point. Okay. Now remains the 3 point. What happens when you take the 3 points? It has a two cases of taking the 3 points. First one, if we take the 3 points A, B and C, which are the collinear points, then what happens? There is a no circle passing through that point A, B, C, which are a collinear point. Okay, which are the collinear points. And when you take in that second case, if we take the three non-collinear points, which are the A, B, C, then what happens? We learned in a previous standard, that means in the ninth standard. Okay, what happens? If we take the three non-collinear points, then how many circles are passes through it? When you join the points each other, we get the triangle. Okay, we get the triangle. And we try to construct a circle passing through the vertices of the triangle. That means the circumcircle of the triangle, which is only one. We learnt in the ninth standard. Okay. How to construct it? Draw the perpendicular bisector of any two sides of the triangle. Okay, any two sides आपण perpendicular bisector construct करें तो point आपण O घेईल ortho center and construct a circle passing through it. That means one and only one circle passing through that three non-collinear points. Okay, that means we conclude that there is many circles, that means infinite circle passing through a single point, also infinite circles passing through the two distinct point, and there is only one circle which is passes through the three non-collinear points. There is no circle passing through the three collinear points. That is the most important concept in our chapter. Understand? Now we are going towards the new concept, secant and tangent. Both the lines are related to that circles. Suppose if we construct a line firstly here, that's like, which is the line L. That line L intersect to the circle at a two distinct point, which is at A and B. Suppose P is the center of circle. Okay. Now we say that line is a secant of circle. That line is known as the secant of circle. But if we construct such lines, look at here. If we construct such lines, I am going on constructing. Every line intersect to the circle in a two distinct point, and at a one time, that a one situation we get here. That means a line touches to the circle at a single point S. Okay, every line intersect to the circle at a two distinct point. At a one time, we get a line which is intersect to the circle at just one point. Then what is the difference between that two lines? A line touches to the circle at a single point. Suppose that the line is M, and line intersect to the circles at two distinct points, which are P, Q, R, S, T, and so on, such a way that. What is the difference between them? The line intersect to the circle in a two distinct point is known as secant of a circle, and the line intersect, or the line and circle having only one point in a common, then that line is known as the tangent of a circle. Okay, then we say that line is known as the tangent of a circle. That means the secant is the secant and circle having a two points are in a common, and tangent and circle having just only one point in a common. Okay, suppose that if we take the O as the center of circle and the line L intersect to the point T to the circle, then we say that line L is a tangent to the circle at point T, and that point T is known as the point of contact. That point is known as the point of contact. Understand? There is a difference between the two lines. First one is secant and tangent. Tangent touches to the circle. Tangent touches to the circle at a single point, and that single point is known as the point of contact. Also, we define it a circle and a line having one and only one point in common. Then that line is also known as the tangent of circle, and the common point is known as the point of contact. And line intersect the circle in two distinct points, then that line is known as the secant of circle. Okay, now look at here in that figure, a point of contact on the center of circle, there is a specific relation. What happens when you join the segment OT? Look at here, we get OT is exactly perpendicular to that tangent at a point T. That means we get the result is that a radius at the point of contact is perpendicular to the tangent, and that is known as the tangent theorem. Now we are going towards the most important theorem, is that the tangent theorem. Tangent theorem. What is the statement of a tangent theorem? The tangent at any point of a circle is perpendicular to the radius at point of contact. That means here given a tangent to the circle at any point of a circle. Okay, and what is to prove? To prove is that it is a perpendicular to the radius at a point of contact. By the given condition, we construct a circle with center O. L is a tangent at a point A. Okay, that means circle and a line having a point A is a common point. Okay, now what is to prove? To prove is that a tangent is perpendicular to the radius at a point of contact. That means here construct a radius OA, which is passing through the point of contact. A is the point of contact, and it is perpendicular to the tangent. म्हणजे इथं आपल्याला ती perpendicular दाखवायची आहे. It is perpendicular to the tangent. That's the given thing. First of all, write the given of that theorem from the figure. O is the center of circle, and L is a tangent to the circle at a point of contact, and OA is a radius of that circle passing through the point of contact A. Okay, and what is to prove? To prove is that tangent L is a perpendicular to the radius OA. हे आपल्याला या ठिकाणी प्रूव्ह करायचं आहे. For that, we are going to write the proof of that theorem using the indirect method. आता ती indirect method काय आहे? Assume that L is not perpendicular to the radius OA. Okay. Then what happens? Now we are going to construct line OB. Sorry, segment OB is perpendicular to the line B, line L, and B is between of A and C, and take a point C on that line L in a such a way that the distance BC and AB are equal. Look at the figure. Now, in a triangle OBC and a triangle OBA, in that triangles, we write here segment side OB is congruent with side OB because it is a common side. Also we write here side angle. Also we write here angle OBC is congruent with angle OBA. Both are 90 degree. Both are 90 degree. And BC is congruent with AB. That's our construction. And therefore, we say that triangle OBC is congruent to triangle OBA by side test of a congruency. Okay, we get OC is equal to OA. Why? That's are the corresponding sides of a congruent triangle. OC and OA are the equal sides or the equal segments or the congruent segments, but OA is radius. OA काय आहे? Radius आहे. And therefore also we get OC is a radius. Okay, also we get OC is a radius. म्हणजे पॉइंट ए हा सर्कल वरती झाला, तसाच पॉइंट सी सुद्धा कुठे आला? सर्कल वरती झाला. And henceforth we say that line L passing through two distinct points, that is a contradiction. Why? Because that line cannot pass through the distinct point. It is impossible. Why? Because it is a tangent. We know tangent touches to the circle at one point, and hence we say that our assumption is wrong, and our correct statement is that the line L is a perpendicular to the radius OA. ओके, म्हणजेच आपण या कन्सेप्टवरून काय प्रूव्ह केलं की OC आणि OA ह्या इक्वल रेडी आहेत, म्हणजे त्या सेम सर्कलच्या आहेत. याचाच अर्थ लाईन L पॉइंट C आणि A मधूनही जाते, म्हणजेच हे कॉन्ट्रडिक्शन आलं, कारण लाईन L ही टँजंट आहे अँड इट पासेस थ्रू दी ओनली वन पॉइंट. दॅट्स इज अ कॉन्ट्रडिक्शन वी गेटिंग हिअर, अँड हेन्सफोर्थ आवर अझम्पशन इज रॉंग. म्हणजे आपण मानलेलं हे चुकीचं आलं. मग करेक्ट काय आहे? तर लाईन L is a perpendicular to the radius OA, and hence we state that a tangent at any point of a circle is a perpendicular to the radius at a point of contact, and hence we prove the tangent theorem. Now we are going towards the converse of a tangent theorem. What is the converse? If a line is a perpendicular to the radius at any point on the circle, then it is a tangent to that circle. Suppose M is the center of circle and the line L is a perpendicular to that radius MN at a point N. ओके, आपण काय म्हटलं की M हा सेंटर आहे सर्कलचा, L ही लाईन MN या रेडियसला N या ठिकाणी परपेंडिक्युलर आहे. त्यावेळेस आपल्याला काय प्रूव्ह करायचं आहे? L is a tangent. Then how to prove it? Look at here, just simple way. Suppose if we take the point P on that line other than the N, आणि तो आपण इथे जॉइन केला, we join the point MP, we get the right angle triangle here MNP. ओके, मग तो राईट अँगल ट्रायंगल इथे तयार झाल्यामुळं we get MP segment MP is a hypotenuse, and we know in a right angle triangle hypotenuse is always greater than the other side. That means hypotenuse MP is greater than MN. Also hypotenuse is greater than NP. आपल्याला जो आवश्यक आहे ते स्टेटमेंट मी इथे घेतो की राईट अँगल ट्रायंगल मध्ये हायपोटेनियस ही इतर साइड जे असतात त्याच्यापेक्षा ती ग्रेटर असते. तशाच पद्धतीने इथं आपण काय म्हटलं की MP इज ग्रेटर दॅन MN, बट MN इज द रेडियस, सेगमेंट MN इज द रेडियस, and MP is greater than MN, and hence we say that point P not lie on a circle. Point P not lie on a circle. Why? कारण MP हा सेगमेंट MN पेक्षा तो ग्रेटर आहे आणि MN ही रेडियस आहे, म्हणजेच MN पेक्षा मोठं असलेलं प्रत्येक अंतर हे कुठं असणार आहे? सर्कलच्या एक्सटेरियर पार्ट मध्ये जाणार आहे, म्हणजेच P हा पॉइंट सर्कल वरती नसणार आहे. ओके, मग याचा अर्थ काय झाला? नो पॉइंट अदर दॅन M lie on line L and on circle. Okay, no point other than N lie on the line and on a circle. That means N is a common point between the line L and a circle, and henceforth we say that line L is a tangent at N. Okay, line L is a tangent at N. Understand? Hence, the converse of tangent theorem is proved. Now, we are going to the next concept, tangent segment theorem. Before the tangent segment theorem, it is essential to learn how many tangents to construct the circle from a given point. Okay, look at here, the circle having a center O and point A is lies on in the interior part of circle. Point B is lie on the circle and a point C is lie in the exterior part of the circle. Then how many tangents are passing through the point A? Okay, the point is in the interior of circle. Look at here. If we take the point A is in the interior of the circle and try to construct the line passing through it, that line intersects the circle in a two distinct points. Hence, we conclude that there is no tangent passing through the point which lies in the interior of the circle. Understand? Now, the second condition. How many tangents are passing through the point lie on the circle? Okay, if we try to construct the tangent on point on the circle, we get the single tangent, one and only one tangent passing through the point which lie on the circumference of the circle. Now, what happened? Now the third case, the point C, which lie in the exterior of the circle. Suppose if we take the circle, point C in the exterior of the circle and try to construct the tangents to that circle, there are exactly two tangents we get here which are passing through that exterior point of that circle. Okay, understand here? When the point in the interior circle, there is no tangent. Point on the circumference of the circle, there is only one tangent passing through it, and the point at the exterior of the circle, then we get the two tangents here. Okay, suppose that AC and BC are the two tangents to that circle. Now we are going to our next concept is that the tangent segment theorem. What is the statement of the tangent segment theorem? Tangent segments drawn from an exterior point to a circle are congruent. We learned here a tangents to circle from an external points. There are only two tangents can be drawn to the circle from its exterior point. Consider a circle with a center A, point B and the exterior of the circle, and line PD and DQ are the tangents passing through the point D touches to the circle at point P and Q respectively. That is our given. Okay, now what is to prove? To prove is that the tangent segments are congruent. Which are the tangent segments? The part of the tangents from its common point and point of contact, which are the segment PD and segment QD are the tangent segments here. Okay. Now, how to prove this? With the help of the previous knowledge, we learned here previously is that the tangent theorem. What is the tangent theorem? A radius is a perpendicular to the tangent at a point of contact. Look at here. If we construct the radii to the circle with center O at a point contact P and Q, we get AP and AQ. That's are the two radii of that circle. Also draw the segment AD. we do the construction here. What is construction? Draw segment PA, segment QA, and segment AD. Okay. Now we are going to write proof. Okay. In a figure, look at radius AP perpendicular to the tangent PD and radius AQ perpendicular to the tangent QD. Give us the region is that the tangent theorem. That means here we write angle APD is equal to angle AQD is equal to 90 degree. Okay, the angles काय झाले 90 degree झाले, and henceforth we say that in a right angle triangle APD and triangle AQD, in both the triangles, in both the right angle triangles, we write here side AP is congruent with side AQ. Give us the reason, radii of a same circle, and henceforth that's are congruent, and hypotenuse AD is congruent with hypotenuse AD. Give us the reason, common hypotenuse. Therefore, we say that triangle APD is congruent with triangle AQD by hypotenuse side test. Therefore, we say that side PD is congruent with side QD. Give us the reason, corresponding sides of a congruent triangle, or that is we write here segment PD is congruent with segment QD, and that is our tangent segment theorem is proved. Now we stop here. We will meet in the next video. Be safe and take care.